Unit 7, Reading 1, page 99.
Pieces of a puzzle. The evidence for pangea. In geology, a plate is a large, rigid area of solid rock. The Earth's surface is built of about 40 plates, called tectonic plates, some as large as continents, and others only a few hundred miles across. Modern geology has shown that these tectonic plates move in relation to each other. Such movement is possible because the plates float on top of the mantle, the layer of molten rock between the planet's outer crust and its dense nucleus called the core. Even before this theory of plate tectonics became accepted, many in the geological community believed Earth's continents had moved during the history of the planet. They were right, but their ideas faced great opposition. Sudden events. Until the 1700s, most Europeans explained the origins of Earth's bodies of water and land masses in terms of catastrophism. According to this explanation, a few sudden, violent events, catastrophes, periodically transformed Earth's surface. Then, a revival of science in Europe restrained the imaginations of geographers. Catastrophism was displaced by uniformitarianism, a term derived from the word uniform. According to this explanation, the forces we see shaping the Earth now are the same forces that shaped it in the past. Since most of the processes we see are slow and gradual, we assume that, for the most part, Earth's surface was shaped slowly and gradually. The belief that continents have not always been in their present positions was common long before the 20th century. In 1596, the Dutch mapmaker Abraham Ortelius suggested that the Americas were torn away from Europe and Africa by earthquakes and floods. As evidence, he pointed out that, if you imagine putting Africa and South America together, they would fit almost like two puzzle pieces. The big opening along Africa's western coast would easily accommodate the hump in South America's eastern coastline. Wegener's theory. More geologists began to think that the arrangement of today's continents gradually evolved. In 1912, a scientific explanation called the theory of continental drift was proposed by a German meteorologist named Alfred Lothar Wegener. He argued that all of Earth's landmasses were once joined in a single supercontinent, which he called Pangea, from the Greek pan meaning all or complete, and gea meaning earth. According to Wegener's theory, about 200 million years ago, Pangea began to split apart. One of Wegener's biggest supporters, Alexander Dutoit, proposed an intermediate stage. He said that Pangea first broke into two large continental landmasses, Laurasia in the northern hemisphere and Gondwanaland in the south. Laurasia and Gondwanaland then continued to break apart into the various smaller continents that exist today. Wegener's theory was based partly on the remarkable fit of the South American and African continents noticed by Ortelius 3 centuries earlier. He and his supporters also offered other pieces of evidence. For example, fossils of an ancient plant called Glossopteris were found throughout the southern continents, Africa, Australia, Antarctica, and South America, and in India. If all these continents had not once been joined, Glossopteris would probably not have spread so far. And if Antarctica had not once been closer to the equator, the plant would not have grown there at all. Geological structures on today's separated continents also offered evidence. Some mountains in South Africa are structurally similar to mountains in eastern Brazil. The coal deposits of Britain match deposits in the Appalachian Mountains of eastern North America. A band of red sandstone stretches from northeastern Europe through Greenland and into Canada. These similarities seemed too numerous to be random coincidences. But how? Wegener's theory, especially his ideas about pangea, took things too far for most of the scientific community. They could accept uniform processes and a slow Africa-South America split, but not split after split and then long-distance travel by the continents. Their strongest objections centered on the question, how? Some scientists tried to show that it was physically impossible for continental rock to move across the ocean floor. Such objections were entirely reasonable, and Wegener's theory had no good answer. Finally, in the late 20th century, the theory of plate tectonics came to the aid of the theory of continental drift. It offered the comprehensive explanation of landmass movement that Wegener had been unable to provide. New evidence made it hard to believe that the continents were not moving. The floor of the Atlantic Ocean was found to be spreading apart. New discoveries showed that the planet's magnetic field is not constant. It fluctuates over very long time periods and has clearly shifted several times. The theory's system of plates moving on molten rock offered a believable answer to the question, how? It integrated pieces of evidence ranging from volcanic activity to the formation of mountains to the distribution of fossil plants. It shows that Pangea not only could exist, but probably did. It also states that the trend toward separation would eventually reverse. The continents will drift together again and form a new supercontinent.